So we know from all that we now have described that time ticks off slower on a moving clock as we're watching it compared to the rate at which time elapses on our clock. And we focused our attention on a light clock, and we showed that the ratio at which time elapses on the moving clock compared to time elapses on the stationary clock is given solely by the ratio of the lengths that the light needs to travel in the two situations. Very long length for the moving clock compared to a relatively short length for the stationary clock. That is the crux of the matter. Light has to travel further in the moving clock compared to the stationary clock. Tick-tocks happen slower in the moving clock, which means less time elapses in the moving clock, more time elapses in the stationary clock. And I've declared, and we're going to work out, what the formula for the ratio of those two times is, and it goes by the name of gamma, the time dilation factor, which is 1 over the square root of 1 minus v squared over c squared, which, except for E equals mc squared, is the most famous equation in special relativity. And if you're doing the math version of this course, we're going to derive that formula in the next section.